Hi, Nicole. This is 6-3. Now we're doing the 3p orbital, the radial wave function. Now the p orbitals have L equals 1, and if 3p is n equals 3, so we're looking for the R31 equation. Here it is, the R31 equation. So we need to find where this thing has a node, at what R, at what R does this thing have a node? So a node would mean that the wave function is 0. There is no probability of finding the electron there. So where does this whole thing equal 0? Wrong color. Where does this whole thing equal 0? Well, let's see. This will never be 0, right? So I can divide that on both sides and just forget about it. Could this ever be 0? Now this can equal 0 when R equals 0. But that's not interesting because, of course, when R equals 0, you're in the nucleus. The electron is not going to be in the nucleus. So I can just forget about this guy too. When can this be 0 or when can this be 0? Now, actually, this guy can never be 0, and that's because the graph of the function y equals e to the here, let me show you this graph here. I forget how to draw it exactly. E to the negative x. So that graph looks like that. This is never 0, right? So look at the y here. So as I go this way, as x gets larger, look, the y is never 0. It's never going to be 0. I mean, we could just go to infinity out here and it will never be 0. It would just be really, really close to 0. Okay, so that's not going to help us. So this is never 0. So the only place where we can get a 0 in a factor of 0 in here, which would allow this whole equation to be exactly 0, is right here. All right. So that means that this has to equal 0 at some point. And at what point would that be? Well, let's solve for r, and that will give us what point that is. All right, and now the r is equal to, and then, all the professors say, and this is nothing more than, so this is what the r is, nothing more than 6a naught over z. And if this is a hydrogen, if this equation is for the hydrogen atom where z equals 1, I think z is atomic number, but if that's the case, it will just be r equals 6a naught. Okay, so that was part A. So in part A, we have r equals 6a naught. I'm going to leave the z in here. You can consult the back of the book for the real answer to see if z equals 1. I assume that we're talking about the hydrogen atom here, but it doesn't specify hydrogen atom, so I'm going to leave the z in there myself, and then you can take it out if z equals 1. Okay, Nicole? Now I will do the next part, which is the minimum and the maximum. And this is going to involve, you guessed it, the derivative again. So I think I'm going to need another piece of paper. Oops. Not that paper. This paper. Yeah. Another piece of paper here. Okay. I'm going to use that equation. And I am going to get the derivative of this at equal to 0 and figure out which r is going to be, which solution for these r's is going to be the minimum and which one is going to be the maximum. So dr. Now all this stuff here does not contain r. So I'm going to call it A again. Right? This stuff in the front, there's no r there. So I'm just going to call that A. I probably won't need it at all. Now this is z times r over a. Okay, now I'm do the product rule again. Function of the yeah, everybody has their own way, right? Oh, wait a minute. I cannot do the product rule yet because I have 3 factors which have r in it. 1, 2, 3. So I'm going to distribute this across this one so I could have just 2 functions that have an r in it. All right, so this is A. So I'm going to rewrite this whole thing. Not the derivative, just r3, 1. I'm going to rewrite the whole thing as a times zr over a naught, distributing over, minus z squared r squared over 6a naught squared, e to the power of negative zr over 3a naught. Okay, so that is r. Now I'm going to find dr dr. dr dr. R! Pirates! Okay. Function of the first one. Right, so a times function of the first one. A naught. This is the function of the first one. Function of the first one. Still doing function of the first one. Times the derivative of the second one. Chain rule. And the derivative. Somebody is playing drums upstairs from us. All right, so function of the first one times derivative of the second one plus function of the second one times derivative of the first one. So derivative of this guy is z over a naught minus 2 all of this times r. So minus 2 z squared r over 6a naught squared. Okay? So, and then close parenthesis and close bracket. So now I'm going to simplify this. By factoring this out. Right? So I will factor that out. And actually, I'm going to set this equal to 0 at this point so that I could just forget about the a and these factors which will never become 0 immediately. So 0 equals, now I'm going to remove the a because a will never be 0. It has no r in it. And I'm going to remove this because I'm going to factor them out. But they will never be 0 because e to the power of negative something will never be 0. So I factor them out and I divide them on both sides and then they're just gone. Right? So then now I have zr over a naught minus z squared r squared over 6a naught squared times minus z over 3a naught plus z over a naught minus, now this 2 cancels with this 6, so I get 1 on top and 3 on the bottom. 3 on the bottom. So that's z squared r over 3a naught squared. Okay, I'm going to distribute this this factor there. So this is 0 equals z squared r over 3a naught squared plus z cubed r squared over 18 over 18 a naught cubed plus z over a naught minus z squared r over 3 a naught squared. So this is z squared r over 3 a naught squared. This is z squared r over 3 a naught squared. So look at those subtract each other and become 0. Now all I have left is this. This I only have one r here. And lucky for me, it is an r squared, so that means I'm going to have two answers, plus and minus. Although, how could you have a negative r? Oh well, we'll figure it out. So I'm going to get a new piece of paper. Whoop. Whoop. Okay, so this means that 0, equals z cubed r squared over 18 a naught cubed plus z over a naught. Okay, and that means that I'm going to subtract this guy on both sides, so negative z over a naught equals z cubed r squared over 18 a naught cubed. Now I'm going to get r squared alone. So I'm going to do, this is negative z over a naught, but multiply both sides by 18 a naught cubed, 18 a naught cubed. Divide both sides by z cubed, and that will cancel this out, and so that will give, so that is now my new r squared. Brand new r squared. This is a z cubed, right? Yeah, that's a z cubed. All right, so this is now a z squared because it cancels with this, and this is now an a naught squared because it cancels with this. So negative 18 a naught squared over z squared equals r squared. And now I have a problem because I need to take the square root of both sides, and that is going to give me an imaginary number, which is not what I wanted. I wanted a real number. Since we are dealing with a physical problem, I need to have a real solution for the r. That means I have done something wrong here. So I will pause this and figure out what I have done wrong. Okay, I found what I did wrong. It is this step right here. So this is a previous page, the previous piece of paper. And I was distributing this guy over there, and I have this plus, but see this negative times this positive, this should be negative. So it is not okay to cancel those out. So I am going to have to undo that. So this should be minus here. This should be minus, all right? So that makes this, I'll start with this guy. So z cubed r squared over 18 a naught cubed minus 2 of these, 2 z squared r over 3 a naught squared. So minus 2 z squared r over 3 a naught squared plus z cubed r squared over 18 a naught cubed. All right, so this is equal to 0. I need to set this equal to 0. So that means the last page that I was working on, before I paused here, needs to be done over again, because what I started with on that page was not correct. Okay, so here I have here I have 0 is going to be equal to all this stuff here, all this stuff. So I would like to simplify this a bit, if possible. Hang on. I had this. I did this first. All right, that's right there, and then I did these. That's right there, and then I should be doing this. Looks like I did this twice. Okay. All this algebra is easy to make a mistake. Sorry about that. So then this last thing should be z over a naught. Z over a naught. Okay. Okay. That is... I might have to use the quadratic equation to solve this. Okay, but I'll just give it a shot. So, can I factor a z out or something? z over a naught. I guess I could factor a z over a naught out. Right, so if I took z over a naught out of here, then I would have z squared r squared over 18 a naught squared minus 2z r over 3 a naught plus 1. Does that help? Not really, but it's better than nothing. Okay, so this will never be 0, so I can just divide both sides by it and just get rid of it in that way. And now I'm going to use the quadratic formula. Yes, baby? Okay, baby. Okay, thank you, Naomi. Thank you. Okay, so I'm gonna do this quadratic formula where this guy right here, not the r squared, but the rest of it, that is the a, and this is the b, and this is the c. All right. So the r is going to be equal to negative. Okay. So sorry, the r is going to be equal to the negative b. All right. So that's going to be positive 2z over 3a naught. Negative b plus or minus the square root of b squared. So this is b, this is a b, so b squared is going to be 4z squared over 9a naught squared minus 4ac, minus 4 times z squared over 18a naught squared. Right, so that was a, 4a, and c is just 1. All right. Well, that looks promising in there. It looks like I can almost cancel something out there. That's good. Yeah, that's very good. Okay, so then this is the whole thing is over 2a, so over 2 times this. So that's going to be 2z squared over 18 a naught squared. All right. Now this 2 can cancel with this 18, so we have 1/9. And I'm going to now subtract what's in here. Now, I want to get a least common denominator. That's going to be 18 a naught squared. So to make this 9 into an 18, I'm going to multiply this whole fraction by 2 over 2. You see what I mean? 2 times 9 is 18, right? So that's going to make this 8 up here and this 18 down here. So 8z squared minus 4z squared is 4z squared. So this is equal to 2z over 3a naught plus or minus square root of 4z squared over 18 a naught squared. That is over z squared over 9 a naught squared. So z squared over 9 a naught squared. Alrighty. Now I am going to get rid of this radical by taking the square root of something. So I like to try to use a blackboard here, and I'm going to get rid of the radical. That's what I'm doing here. So this r, okay, so r is equal to 2z over 3a naught squared, 2, so 2z over 3a naught plus or minus. Now, I'm going to take the 4 out, so that'll give me 2. The z squared out, that'll give me z, so it's 2z over, and then over a naught squared, that'll give me a naught, so that's, oops, where's my new paper? Okay, so that's going to be 2z over a naught, and then I can take a 9 out of here, so that'll be a 3. So 3, but then 9 times 2 is 18, so 2 is going to stay in there. 3 root 2, like that. Okay? All right, and now this is divided by, all this is divided by z squared over 9a naught squared. When you divide, that's like multiplying by the reciprocal. So 9a naught squared over z squared, like that. Okay. So the r is this plus or minus all that stuff. And I can take an a naught out. I can take a 2 over a naught out. I can take a 2 over 3 a naught out. So let me do that. So r is going to be equal to z plus or minus 2 over a. I'm going to take this out. I'm going to take this out. This is plus or minus z over root 2. Yes, yes. I'm getting two positive numbers from here. That's excellent. All right, so this is 2 times 9 is 18 a naught squared over z squared. So another a naught, so that's a naught and a 3. Right, so that's a 3. Right, so that is really just z plus or minus z over root 2, and then times, so this cancels with the 18 to get 6, and this a naught cancels with this a naught, so I have 6a naught over z squared. All right, now I can also take out a z here. I don't know why I didn't think of taking out the z. Sorry about that. I should have taken out the z right at this point, but I'll do it now. All right, so r equals, so I'm going to take this z and put it over there. So this is going to be 1 plus or minus 1 over root 2, 6z a naught over z squared. Okay, this cancels with this. As you could see, math is not something that comes entirely easy to me. 6a naught over z. Okay, so now I have two answers here. One is the maximum, and one is the minimum. Let's see here. And to find if which is which, I could use the second derivative test. All right, so here we go with a new piece of paper. I could also use the smiley test. You remember the smiley test from your math class? I think I prefer the second derivative test, actually, sometimes. Okay, so 1 plus 1 over root 2. Okay, so r is equal to 6a naught over z times 1 plus 1 over root 2, or 6a naught over z times 1 minus 1 over root 2. Right? So, which is the maximum and which is the minimum? Well, let's see. This is the larger number, this is the smaller number, and this is the p. This is the 3p, right? So the 3p is going to have there's going to be a spot for the 2p and a spot for the 3p. So I think this one would be the maximum, and then let's look at a graph of this. I could use the second derivative test, but if I could just look at a graph, that's what I'd rather do. So 3p radial wave function graph. 3p radial wave function. 3p, 3p radial wave function. Okay, I don't have flash here. Sorry about that. Okay, 3p. Maybe I will look at the pictures. I like this website. Hydrogen radial probabilities. Okay, all right. So this is radial probability. This is probability. Okay, probability is the wave function squared. That's not what I want. I want the actual wave function like this. Yes, like this. 3p. I don't know what this fractional subscript is, but 3p is something like this. So, wow. I don't know if we just found. I don't know if we just found this point or this point. We found r equals this or r equals this. You know, I think I am going to have to do either the second derivative test or the smiley face test. Okay, that's too bad. I thought we were going to be done. Okay, so what was the 3p wave function? Okay, it was this. Right now, I could take the second derivative, but that would take a long time. So maybe I will do the smiley face test. So, wow, even the smiley face test would take a long time. Jeez. Okay. So I have found that this function has a zero derivative, meaning it has a relative extremum at this large r, and at this small r. All right. So I really don't want to do any of the derivative tests. I really want to use a graph. Okay, so it has actually there should be three. There should be three relative extrema of this. Maybe I have the wrong wave. Oh, this is the f orbital. Okay, so I need to look at a graph of the p orbital, 3p. This graph right here. Okay, so this is a graph of the radial part of the 3p. Notice that when I'm looking for graphs, I'm looking for something that has stuff that goes below the x-axis. And because I do that because if I only see stuff that goes above the x-axis, that means I'm looking at probabilities, which means I'm looking at the radial function squared. But I don't want the radial function squared. I want the radial function. Okay, so there are indeed two relative extrema. There's one right here, and there's one right here. This one is the larger one. Therefore, that one's the minimum, looking at 3p. And the smaller one is the maximum. Right? So that means the larger one, this is the minimum. And this one is the maximum. Yay! All right, so I have found for you the minimum, the maximum, and the node. And the node was on the previous page. So, our previous page. And the way I found the minimum and the maximum was not by the second derivative test, not by the smiley face test, but by something completely out of scope of math class. I used the actual graph of the radial function, and I found that it has a flat slope here and a flat slope here. This is the larger r, where the x-axis is r. This is the larger r, so this was the minimum. This was the smaller r, so this was the maximum. Larger r is something times 1 plus something, and the smaller r was something times 1 minus something. They're both positive, but one's larger and one's smaller. Woo! Thank you, Nicole. Love doing these problems.